Hello everyone, my name is Paul Forsyth from RTDS Technologies, and I want to thank you for joining this presentation. Congratulations to everyone involved in organizing IPST 2021, as well as thank you to all of the participants. We hope everyone will enjoy the event and gain valuable information from the experience. We have all been struggling to various degrees due to the global pandemic. We at RTDS Technologies wish the best to everyone, and we look forward to getting back to in-person meetings as soon as it's safe to do so. Before continuing with my main presentation, I wanted to mention that RTDS Technologies has two papers included in the proceedings of IPST 2021. The first paper was presented by Dr. Jedai Liu this morning during the real-time simulator session. The paper is titled Development of Phase Domain Frequency Dependent Transmission Line Model on Fpga for Real-Time Digital Simulator. The second paper will be presented by Dr. Ali Dakordi tomorrow during the Renewable Energy session. The paper is titled A Multi-Star Synchronous Machine Model for Real-Time Digital Simulation and Its Application. I would like to take time today to briefly introduce some of the new developments released for the RTDS Simulator since the last IPST conference. One of those important developments was the release of RSCAD-FX in April of this year. The development updated the look, feel, and handling of RSCAD, primarily the draft module. During the development, enhancing productivity and improving ease of use were high priority design targets. Here you can see the new look of the draft module. It is very customizable with resizable panes which can be undocked and redocked to maximize the workspace using multiple monitors. The look of the component library has also changed, and features have been added to improve the navigation and search features to make it quicker and easier to find components. Other new features targeted at making the development of simulation models faster and easier are wire mode and auto naming. Wire mode makes it exceedingly easy and fast to make connections between library components with just a few clicks of the mouse. Auto naming is an extremely powerful feature. As new components are added to from the component library or copied from within the simulation case, the component and all of the associated variables are automatically renamed to avoid conflicts. In fact, entire groups of components, for example an entire HVDC station, can be copied within the case and all of the associated components and variables will be automatically renamed. And of course, RSCAD-FX is completely backward compatible, so that cases that were developed in version 5 can be loaded directly into RSCAD-FX. Another very exciting development is the UCM, or Universal Converter Model. We believe this model greatly enhances our power electronics modeling capability. The UCM model was developed due to demands to represent high-frequency switching of power electronic converters in excess of 100 kHz. The model is aptly named the Universal Converter Model because it can represent multiple converter topologies, it has 3 different input modes, it can be used for software in the loop as well as hardware in the loop simulations, and it can operate both in the sub-step and main step environments. Currently the following topologies are available in the UCM: 2-level, NPC, T-type, boost, buck, and flying capacitor configurations. It goes without saying though that other converter configurations will be considered for future development. The UCM has 3 different input modes. The first is the modulation waveform input, which behaves like an average model representation and does not include switching harmonics. The second is the full firing pulse input, which is essentially the same as our existing sub-step resistive switching models. The third and most exciting option is the improved firing input, which provides performance similar to interpolation. In this mode, the firing pulses are captured during a simulation time step to formulate an effective duty cycle for each IGBT. Of course, multiple turn-off and turn-on transitions are allowed within one simulation time step. We have also developed the new GTDI V2 card in support of the UCM. The GTDI V2 card is used to provide improved firing input to the UCM when testing with external control for controller hardware in the loop. The GTDI samples the input every 5 nanoseconds to capture the firing pulses with very high accuracy. There are very significant benefits to the UCM model. It can accurately represent frequency switching over 100 kHz when operated in the substep environment. The UCM does not require decoupling of the converters at the DC bus, which provides a very stable and accurate simulation. Even when operated at a 50 microsecond time step, switching frequencies of a few kilohertz can be accommodated by the model. The UCM properly represents the transition between the blocked and deblocked states using our predictive firing technique. An analytical frequency scan capability was added so that the system impedance profile can be analyzed. The scan is performed offline in draft, and the output is made available in a file with various output formats included. An online harmonic scan capability was also added. The harmonic scan capability injects small magnitude white noise into the system and measures the response. The scan is conducted during a simulation run, so the response includes both the network and control dynamics. A procedure has also been created to determine the Nyquist dipolity criterion based on eigenvalue analysis. New transformer models have been developed based on terminal duality approach. The new models provide more realistic representation of internal faults than can be provided using the popular star equivalent circuit. The terminal duality approach also allows for mutual coupling between the branches of the equivalent circuit and the traverse component of the leakage flux to be taken into account. We have made a number of enhancements to our FPGA-based MMC valve models, some of which came from practical experience gained through projects like the Kun Liu Long multi-terminal UHVDC project in China. The Kun Liu Long project was particularly interesting. A couple of highlights are that it is a multi-terminal project with 2 MMC-based terminals and 1 LCC-based terminal. Another interesting feature is that the MMC valves are a mixture of both full and half-bridge submodules. In order to provide thorough testing of the control and protection scheme, we have developed a number of internal valve fault options for the MMC valves. There's an option to include a fault point along the valve that can be connected to any other node in the simulation, typically connected to ground or to the valve in the adjacent phase. A submodule capacitance can be changed at any time during the simulation or short-circuited. We can also simulate a submodule IGBT fault or a reactor fault. There have also been considerable developments made in the area of protection and automation. Many of those relate to IEC 61850 or IEC 61869. A new ICT tool was implemented in RSCAD-FX with configurable support for all logical nodes. The GSE V7 firmware has 4 configurable IEDs supported with the new ICT tool. We've also added routable goose and sample value messages. A functionality for 250 kHz sample value output was added for support of FACS and HVDC projects. Additionally, a sampled value data manipulation feature was added to enhance the testing of IEC 61850 compliant devices. Enhancements were also made to the PMU test utility as well as to the DNP and Modbus firmwares, plus numerous relay models were added to the component library. Traveling wave-based relay models are gaining acceptance, and the RTDS Simulator is being regularly used to test them. 2 options are available: the GT-FPGA TWRT or NovaCore. GT-FPGA TWRT is an FPGA-based simulation for smaller network models which can be used together with either PB5-based racks or NovaCore. This approach uses a time step which is fixed at 1.54 microseconds. NovaCore uses the substep environment to break the network model into smaller portions mapped to different cores to keep the time step in the range of 2 to 3 microseconds. Larger network models can be accommodated by using multiple cores and even multiple NovaCore chassis if necessary. Both of these approaches use phase domain frequency-dependent traveling wave-based models. A number of RTDS customers are using the simulator to perform TWRT testing. A direct connection between the simulator and the relay is required since amplifiers do not provide the necessary frequency response to test these high-speed relays. Not all of our new developments have been focused on software. We have also made many new developments for the RTDS simulator hardware. On the NovaCore platform, we have added a UDP port for real-time Ethernet-based data streaming. A controlled shutdown feature was added for high-power PHIL applications, and we implemented a snapshot so that you can restart a simulation from any captured point in time. Pretty much all of our peripherals have been updated with new features, including updates to the GBH and IRC switch to support interconnection of up to 144 NovaCore chassis. We have even added support for longer cables. GBH and IRC cables can be up to 100 meters when using the latest platform, and I/O cables can now be more than 300 meters. I've only highlighted a few of our recent developments, but the list actually goes on and on. Finally, I wanted to mention some excellent resources to get more information about the latest regarding the RTDS simulator. First, we've released a number of webinars and informational videos on our YouTube channel. There is also the RTDS knowledge base where you can easily search by topic or component to find information you are interested in. And of course, there's our general website where we feature the latest updates on the RTDS simulator as well as our upcoming events. If there is anything you can't find, or if you would like any additional information on the RTDS simulator, please reach out to us at marketing@rtds.com. Thank you for your attention. We have a few minutes before the next session, so if you have any immediate questions, please send them to us now.